terrifying. Yet accidents like these happen far more often than we'd like to think. In fact, while I'm up here, 20 people around the world will die in a motor vehicle collision. Oftentimes during an accident, we blame the driver by saying that they were doing something wrong. They turned or they weren't looking. But what if I told you it wasn't a person's fault? What if I told you the road itself is the problem? Every year, the American Society for Civil Engineers provides a report card for our infrastructure. In 2017, America's roads received a D. But there's hope. These same civil engineers provide a series of ways to get away from this failing grade, to improve it. Ultimately, their recommendations, though, rely on understanding roadways at a new fundamental level. That's why we built CrossRoad Optics. Using a small hardware sensor, we were able to collect visual data and then quantify that data. Here you can see our system is classifying and tracking cars, bikes, and pedestrians moving through this intersection. So how does it work? We take visual data, collect it through a hardware sensor, and do some processing on site where it's set up. Then that data is then offloaded to our cloud-based computing system. There we use computer vision and machine learning to run a series of advanced analysis on the intersection or site. That produces some outputs that kind of look like that, which nobody really knows what that means, right? So from there, we are now creating a live data dashboard. Once our sensor is installed and continually monitoring, our data will be live streamed to the customer so that they can see on a dashboard. Currently, we're implementing a road user count and vehicle speed tracking. We will also have time comparisons so that you can track what's the busiest period of time at your site. In the future, we also plan to expand this to include metrics like heat map by user type. This will allow you to see where pedestrians are walking the most commonly, and also see the one-offs, where is somebody jaywalking. We will also implement a comparison over distance. This means that we can compare two sites to each other, and that is crucial for understanding and comparing the safety of your intersection to somebody else's. We've identified two major groups who are interested in the data we can provide. First off, advocacy groups are interested in the data because we allow them to quantify their work in improving traffic safety. For them, when they go out, they want to improve a local neighborhood. So they'll set up one of our sensors. They'll prove that cars are speeding down their roadways. And then after they apply an intervention, they can also use our system to prove that their intervention slowed traffic and increased safety. Our other market is retail developers. Retail developers are very interested in the count data that we can provide. Say we have a retail developer who has a huge site. They'll have a customer move in and lease one of their storefronts. If it's CVS, then when CVS comes in, they'll track the counts before and after and show that after CVS moved in, there was a 20% increase in foot count traffic. This is great for them, and they can prove to other new leasers why they should move into the site. So far, we've run a couple of case studies. The first one in November 2016 in downtown Needham. At the time, there was an ongoing construction project, and we got in right at the beginning. There, we collected a day's worth of data, and we processed it. A local advocacy group, the Needham Heights Neighborhood Association, was interested in the data that we were generating. So we met with them, and with their interest, they wanted us to monitor again next fall when the construction is complete to show the differences that the construction has had in the intersection. Just recently, as this past Sunday, we had our last case study. There we were working with the Open Streets project in Newberry. If you're not familiar with the Open Streets project, what they do is they take a normally busy roadway, which is used by cars, pedestrians, and bikes, and close it off to cars. This creates a new kind of dynamic. Pedestrians are allowed to roam freely, as you can see in the image there. The city was so excited by the amount of data and the way we were able to show them the change that this project had, that they want to continue to work with us for the next 2 months at this site, not only as a partner, but as a customer. So who's behind CrossRoad Optics? Currently, the team is comprised of myself and Ryan Louie. We're both recent graduates of the Olin College of Engineering, where we've worked on this project for the past year under the mentorship of Professor Alan Downey, who's an author of many books in computer science and data science. This project has also been done in conjunction or in partnership with the Santos Family Foundation. This foundation is dedicated to reducing road-related deaths and increasing road safety. Together, we see a future where the data we are creating helps drive decisions in road safety and development. We believe that we can truly create a map to a safer future, but there are some ways in which we need help. Currently, we are looking for advisors in the retail development and expansion space. This is a new area for us, and we're very excited to work in it. We're also beginning talking to early stage investors. And the last part, as always, we need intros to retail developers and advocacy groups, those who are hungry for our kind of data now. So if you know anything in these categories or just want to talk to us about how we're trying to help improve road safety, please stop by our booth and talk to us. Thank you.